Have you ever just looked up at the night sky and wondered about the silent, invisible rules that are running the whole show? I mean, it's not just random movement up there, it's a performance, an immense, elegant, and sometimes surprisingly chaotic ballet. Okay, let's dive right into this cosmic waltz. For basically all of human history, we've been trying to figure out the strange behavior of the planets. We've gone from just staring up at the sky to sending incredibly powerful spacecraft out there. But the core question? It's still the same. What's the choreography that makes these worlds turn? That's what we're going to get into today. So to really understand the rules, we first have to go back to the original dance floor, to a time when humanity was absolutely convinced it was the star of the show. At its heart, this is what we're talking about, celestial mechanics. Now, it sounds super complex, but the goal's actually pretty simple. It's all about predicting where things are going. Doesn't matter if it's a planet, a rogue asteroid, or a satellite we launched ourselves. It's the science of cosmic clockwork. For most of human history, our view of the universe was, well, geocentric. We thought everything, and I mean everything, revolved around us. It was a simple, kind of comforting idea, right? But way back in ancient Greece, astronomers like Aristarchus had this radical thought, a heliocentric system, with the sun at the center. It was an idea that would take almost 2,000 years to really catch on. But the big takeaway here is just how powerful that first simple idea was, that we were, literally the center of everything. So, how did we go from being the center of it all to just another dancer on the floor? Well, it took a complete revolution in thinking, a brand new choreography for the entire cosmos. And this pretty much shows the two biggest steps. First, Copernicus moves the spotlight, putting the sun right at the center of the solar system. Then, Kepler comes along and refines the dance itself. He realizes the planets weren't moving in perfect heavenly circles, but in these stretched-out ovals we call ellipses. All of a sudden, the universe was less perfect, but a whole lot more interesting. And this reveals something huge. The cosmos wasn't following rules of divine perfection, but actual, observable, physical laws. Now, these were incredible breakthroughs, for sure, but they described the what, not the why. The universe still needed a director, someone to write the actual fundamental rulebook for this cosmic waltz. And that person was Isaac Newton. I just love this story from the book's foreword. It perfectly captures the heart of the whole thing. Celestial mechanics, with all its beautiful complexity, really just boils down to one powerful, all-encompassing idea: gravity. But, as the professor says, you've got to know it very well. And that's the real genius of the Newtonian synthesis. The insight here is absolutely revolutionary. One single, elegant rule, gravity, governs both an apple falling from a tree and the moon orbiting the Earth. For the first time, the universe seemed like this grand, predictable machine, a perfect clockwork we could calculate forever. Or so we thought. Yeah, because just when we thought we had the perfect, elegant rulebook for the cosmos, a plot twist popped up, a complication that revealed this hidden, chaotic side to this beautiful dance. So the crucial point is this. Newton's math works perfectly for two things, say the Earth and the Sun. You can predict their orbits with amazing precision, but add just one more body to the mix, the Moon, for example, and the math just breaks. The elegant equations no longer have a simple, single solution. The dance becomes totally unpredictable. And what's really cool about this slide is how it just shows you that jump in complexity. On the left, you've got the two-body problem, clean, stable, predictable. On the right, the three-body problem, a tangled, chaotic web where the tiniest change in where you start can lead to a wildly different ending. And the big takeaway here is that even a perfectly predictable system, following simple rules, can create complete chaos. Order, it turns out, has the seeds of its own chaos baked right in. Now, this might all sound like abstract history and theoretical math, but understanding this dance, both its order and its chaos, is more critical today than it has ever been. So let's see how this cosmic waltz plays out in our world, right now. Our solar system isn't just 8 planets waltzing around in an empty room. Oh no, it is a very crowded dance floor. To date, we've cataloged over 100,000 asteroids, and there are countless more out there. Navigating this system, well, it requires a masterful understanding of celestial mechanics. And this is why it all matters so much. Every single time we launch a mission to another planet, we are using celestial mechanics. When we track an asteroid that might pose a threat to Earth, yep, that's celestial mechanics.
Even managing the cloud of human-made junk orbiting our planet, or hunting for new worlds light years away, it all relies on these very same principles. The bottom line is, this ancient science isn't just history. It's the fundamental map we use to navigate our future in space.
Which brings us to a final really fascinating thought. We live in a solar system that seems so stable, so orderly, but we now know it's got these deep undercurrents of chaos. So, is the stability we enjoy a fundamental rule? Or are we just part of an incredibly long-running performance, a chaotic dance that just so happens to have been perfectly in sync for billions of years? And we're left to wonder when or if it might ever miss a step.